Here we go. Our title, section 9.2, it says, part 2, velocity time graphs. We already looked at distance time graphs, and the key idea with a position time or a distance time graph, when you had like meters on the y-axis and time on the x-axis, was the slope of that graph told you something. Who remembers what the slope of a distance time graph was? Does anyone? Began with the letter V. It's velocity. The slope of a distance time graph is the velocity. What we're going to ask ourselves today is, all right, what about the slope of a velocity time graph? So first of all, the motion of an object with uniform motion is best represented by a position time graph. Say what? Laura, if you're not speeding up or slowing down, if there's no acceleration, if you're traveling at a constant speed, and the fancy word for that was uniform motion, a position time graph is pretty good because it gives you nice straight lines on that graph. However, the motion of an object with a, what's that an abbreviation for? Changing velocity or an acceleration is best represented by a velocity time graph. And you're going to see why in a second. And here is the key idea for the day. In fact, later on, I think I wrote it in huge cap letters. We're going to put a big star, a big asterisk, a big circle around it. Turns out the slope, the rise over the run, the slope of a velocity time graph is the average acceleration. The slope of a position time graph, Hayden, is the velocity. The slope of a velocity time graph, Hayden, is the acceleration. You writing this down? You are now. So, and quick reminder, just to jog our memory, acceleration is measured in what? Meters per second squared. So turn your brains on. If you focus for the next 10 seconds, then everything else after this should make sense. It'd be tricky to wrap your brain around, but it should make sense, at least when you think about it. Here is a velocity time graph. How can I tell this is a velocity time graph? Well, there's a title, Mr. Durick. It says velocity versus time. What if it didn't say that? Well, look on the y-axis. I will never give you a blank graph. What is on the y-axis? What's labeled there? Velocity. And positive means what? Forward. Okay? Could mean north, could mean up. In this case, positive means forward, and time is on the x-axis. So here's what I want you to notice. At time 0, right here, how high are you? 0. Your height on a velocity time graph is how fast you are traveling. Okay, I need you guys to focus. So, after 1 second, how fast are you traveling? Now, you're going to have to kind of eyeball it and take your best guess. How high is that? How fast are you traveling after 1 second? I don't think 15. I think 15 would be exactly up. I think about 12 and a half if you really want to. I think about 12 and a half. I think after 2 seconds, how fast are you traveling? 25. After 3 seconds, how fast are you traveling? Here's my point. Are you traveling at a constant speed, or is your speed changing? Changing. I said here, analysis of motion. If you find the slope, which is the rise over the run. And let's use these 2 points right here. The rise is that distance right there. How high are you at the very, very top? 50? How high are you at the very, very bottom? What's the rise then? If you end up at 50 and you start 25 high, what is your rise? Also 25, conveniently. I tried to pick some nice numbers. Over. What's the run? Well, we started at 2 seconds. We ended at 4 seconds. What's our run? What is 25 divided by 2? Now, in Math 10, we would leave the slope as a fraction, but we said in Science 10, we like it as a decimal. We wanted to evaluate it. What is 25 divided by 2? That's the slope. This is also the velocity. And there is a way that you can remember that. There is a way that you can remember that. Slope is what over what? So if I go rise over run, which we said was 25 over 2, what I didn't put in my earlier fraction, Dylan, was the actual units. Look on the y-axis. What are the units on the y-axis? What did I write next to the word velocity? The rise is measured in meters per second. Look on the x-axis. What are the units along the x-axis? What did I write next to the word time? Can you see when I go rise over run, the units go meters per second per second? It's meters per second divided by second. And what is another way to write meters per second per second? It's meters per second squared. You can actually kind of, if you're clever with the units, say, oh, the meters per second squared, the acceleration pops out when I, instead of going numbers rise over run, if I go units, y units rise over x units run. That's one way to remember it. In fact, Physics 12, that's how I teach my kids to memorize every graph. We don't memorize them. So you want to know what a graph is? Divide the y units by the x units. That tells you the slope. Sorry, folks. I made a dump. This is not the velocity. This is the acceleration. Can't believe I did that. The slope of a velocity time graph is the acceleration. Let me say that again. The slope of velocity time, oh boy, this is going online. All my kids that watch this online are going to think I'm dumb. This is also the acceleration because it's meters per second squared. You must be accelerating because your velocity is getting bigger. Here's our key idea. The slope of a velocity versus time graph is the acceleration. This is what I want you, Kenzie, to come out of this lesson with. And all we're going to do for the next few minutes is try and find different ways to apply this. Turn the page. So there are 3 types of motion graphs. There are 3 types of motion graphs. Position versus time. Velocity versus time. And acceleration versus what? Take a guess. Time, yes. Okay. So I gave you 3 examples right here. Once you've written the 3 types, put your pencils down and just look up for a second, but don't zone out. I'm going to zoom in on the acceleration graph. But I'll wait till you all get the 3 oh, you can get the 3 different types by looking at the 3 different types of graphs. I'm going to zoom in. This graph right here, this one, is the graph of, what are we measuring on the y-axis? That means how high you are is what your acceleration is. How high are you at time 0? Look at the numbers, do the math. At time 0, how high are you at time 0? 2.5. How high are you after a half second? How high are you after 1 second? How high are you after 1.5 seconds? Okay? This is a constant acceleration. You know how I know? Because the acceleration didn't get higher or lower. What's the acceleration? According to this graph, the acceleration is 2.5 meters per second squared. It's constant. What if I didn't give you that graph? What if instead I gave you this velocity versus time graph? This middle one. Is it a constant velocity in this middle one? Everybody say no. A constant velocity would look like this. Because I would say, now your height is velocity. How high are you at time 0? 3. How high are you at time 0.5? 3. How high are you after 1 second? 3. By the way, what's the slope of a horizontal line? What's the rise over, huh? If you have a constant velocity, what's your acceleration? Not forward. What's your acceleration? Someone said it. Uh-huh. 0. Right? If you're constant velocity, you're not accelerating. What's a number that would describe not accelerating? An acceleration of what? 0. Ready? Scene 1, act 1, take 2. We're going to repeat it again. If you have a constant velocity, if your graph is a horizontal line and it's a velocity time graph, that means your velocity is the same as the same as the same as the same. We call that uniform motion. That means you are not accelerating. It means your acceleration is 0. Is that what I have in this situation? No. We're speeding up. See it? And if I go rise over run, if I went rise over run, the slope of this is the acceleration, and that would give me 2.5. Trust me. What if I didn't have that? What if all I had was this position time graph? How could I figure out that you're speeding up here? On a position time graph, what's the slope? Velocity. The slope is the velocity. Now take a look at the slope of this graph. First of all, is this graph here a line or a curve? A curve. But we did say that the slope is how steep you are. Is this graph getting steeper or shallower as time moves forward? Steeper. And what did we say the slope was on a position time graph? Velocity. If your slope is getting steeper, your velocity is getting bigger. Say that again. If your slope is getting steeper, your velocity is getting bigger. If you gave me this graph here and I said, oh, it's position versus time, I'm speeding up. Look. Starting out at that velocity, speeding up, speeding up, speeding up, speeding up, speeding up, speeding up, speeding up. A curvy position time graph means you're accelerating, the velocity is changing. A straight line, non-zero slope, velocity time graph means you're accelerating. Your velocity is changing. If that's a velocity time graph, you're not accelerating, you're at a constant velocity. If you have a position time graph that's flat, what's the slope of a flat line? What's the slope of a horizontal line? 0. And if on a position time graph velocity is slope, a horizontal position time graph means you're standing still. Your velocity is 0. It's a lot to keep track of, I know. We can use each type of graph to analyze the motion of an object or compare the motion of two different objects. So let's write some of this down. An object with constant acceleration has a, instead of writing velocity time, can I go v dash t, is that okay for an abbreviation? Has a velocity time graph that is a straight line. As an example, v, t, there's an object that's speeding up. Oh, what would an object look like that was slowing down? Oh, negative slope, downhill. What would an object look like that was traveling at a constant speed? All lines are straight, Captain Obvious. Horizontal line. Okay. Remember, key idea, the slope of a VT graph, of a velocity time graph, what are we saying the slope of a velocity time graph is? Key idea, what's the slope of a velocity time graph? Acceleration. Okay. Then I debated leaving this line in or not. This is Physics 11, so you can make a little note here. Not on test, but for what it's worth, Kenzie, the area under a VT graph represents displacement. I don't believe that's on the provincial. It won't be on your test. And if I'm wrong and it turns up on the provincial, I apologize. But when I read through the exam specs, I didn't see they were going to ask you that. But I'm a nerd, Sarah. I got to at least throw it in here because how can I resist? Oh, and we already said this. A negative slope on a VT graph, if you have a velocity time graph that looks like this, do you have positive acceleration or negative acceleration? Negative acceleration. I think now I hope, yeah, I get into a bunch of pictures. Good. It's easier to do with pictures. So you ready? Turn the page. Here is a position time graph, and we're going to see if we can sketch the velocity time graph to go with the position time graph. Take a look at the position time graph. Can you see, first of all, Hayden, I think I want to divide it into 3 chunks because there's a and then a horizontal and a down. And more specifically, how many seconds long is the first chunk? 4. You know what? Really lightly just kind of do a dotted line right here at time 4 seconds. Our first chunk is going to exist in that little section there. How many seconds long is the second chunk? 8, it's right at 8 seconds, so I'm going to also 4. Okay. What is this second graph? What are we graphing? What versus what? Velocity versus time. Now, where does velocity show up on a position time graph? In the slope. So see that first section? Find its slope. Go rise over run, please. Find the rise over run of that section right there. What do you get? Okay, I'm going to make a little note, yoink, right here. Slope equals 6 over 4, or as a decimal, please. As a decimal, please. Jacob. Okay. And because slope is velocity, was that Josh that said that? Sorry. I just heard it coming from back there somewhere. So let me say this again. This is important. Leah, my angel, in the first 4 seconds, what's the slope of my position versus time graph? Read me what I'm circling. In the first 4 seconds, what's the slope of my position versus time graph? What's the velocity? 1.5. Say that again. You ready? Scene 1, Act 1, take 2. Here we go. In the first 4 seconds, what's the slope, Leah? What's the velocity in the first 4 seconds? If I'm graphing that, that means that there would be a line 1.5 high, like that. Okay? You see it, Dylan? 1.5 high. Let's look at the second section of the graph. The second section, this one. What's the slope? Okay, I'm going to make a little note here. So between time 4 and time 8, what's the slope? 0. What's the velocity? Same answer. 0. So on the velocity time graph, I'm going to draw a line how high? 0 high. It's going to look like this. Like that. So far so good, Justine? Baby steps here. Ooh, the third section. What's the slope? First of all, it's negative, downhill. Oh, negative 6 over 3, or if I write it as a non-fraction, what? Negative 2. What that means is we're traveling negative 2. Now, how would I show that? Well, Mr. Dewick, you didn't give me enough room on the graph. I just realized I should have given you some numbers down here. Negative 2 would be here, here. You know what? It would be like that. Negative 2. A horizontal line, negative 2 high. This is so much fun. Let's try another one. Okay. Yeah. Oh, I forgot to give you negatives on your velocity graph again. I'll have to retype this. Oh, well. I think this position graph, I'm going to go with 1, 2, 3, 4, 5 little sections. And we're going to see if we can sketch the velocity time graph that goes with it. First section here, what's the velocity? Well, what's the slope? Negative what? I think negative 4 over 2, isn't it? Because you start negative 2 high, you end negative 6 high. I think your rise, Sarah, is 4, yes? Yes? So the slope is negative 4 over 2, or in lowest terms, negative 2. So once again, we're going to have to add a couple of lines. How many seconds are we traveling at negative 2 meters per second? For how many seconds? 2. So I'm going to draw a horizontal line right there. What about this section? What's the slope? So how fast are you traveling right there? Brady. That's going to be a horizontal line 0. How many seconds? Isn't it from 2 to 4? 2 seconds, right? A horizontal line 0 high, just like that. Then what? We start to speed up. Let's go. What's the rise over the run on that section? $18 over what? I missed the last digit. 3? How fast are we traveling between time 4 and time 7? 6. So between time 4 and time 7, I'm going to draw a line 6 high. That's terrible. I can do a little better than that. We sped up. Oh. What's the slope of this section? Negative 12 over 3. So our speed is actually negative what? Negative 4. Nope, we got to add a couple more. Boom, there's negative 3. Boom, there's negative 4 right there. And that's between what two times? 7 and 10? Times 7. Oh. And times 10. Like that. Sorry, Sarah, I didn't give you enough graph paper. I'm kind of eyeballing it. But negative 4 is about down there, yes? Is that okay? Yeah. That's my fault. Oh, and then this very, 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 very last section here. Oh, we're traveling 0. So from, oh, change colors, Mr. Duke. This little jagged thing, line, 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 line. This little slope, this line, 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 line. That's the velocity time graph for that little trip. On your test, I'm probably going to give you a couple of graphs to identify or to analyze like this. Let's try a couple more. Turn the page. Is there a graph here? What kind of a graph? What are we comparing? What versus what? Look at your y and x axis. Okay, this is velocity versus time. So when I see velocity versus time, I think, oh, the slope is not velocity. What's the slope of a velocity time graph? Our key point for today? Acceleration. Are you ready? Here we go. Question 1 says, during which time interval was the acceleration 0? I think to myself, during which time interval was the slope 0? Because the slope is the acceleration on a velocity time graph. Look at, huh? Sarah is rocking and rolling between t equals 8 to 10 seconds. In which time interval is the acceleration positive? Sorry? I missed that. 0 to 10? Sure. T equals 0 to 10 seconds. What that must mean, Hayden, is you sped up, sped up, sped up, sped up, sped up for the first 10 seconds. When you hit 10 seconds, you cruised at a steady speed for 2 seconds. See it? The little horizontal line. Oh, and then, Hayden, what's that representing? Yes! When is the acceleration negative? What time intervals, Hayden? Between... You should tell me you're not ready more often. Now, the other phrase we can use instead of saying acceleration, we can say increasing velocity. So number 4 says, hey, what time interval is it increasing its velocity east? Oh, by the way, the acceleration positive, you're right, Josh, you were pointing out, it's not from 0 to 10, is it, Sarah? It's actually from 0 to 8, unless you count 0 as a positive number. Actually, 0 is neither positive nor negative. It's kind of a nothing. So I should have fixed that. Yeah, increasing its velocity from 0 to 8 seconds. When is it decreasing its velocity? From t equals 10 to 14 seconds. When is it moving at a constant velocity? Okay. Ooh, a little tougher one. What are we graphing here? What are we graphing here? Position versus time or velocity versus time? Okay. During which time intervals was the acceleration 0? Think slope. In which time interval or intervals is the acceleration 0? T equals from 2 to 4. And there's another one. From 10, I think it goes to 12. Yes? Where is the acceleration positive? What time interval? From 4 to what? 7? Where is the acceleration negative? I think there's 2 intervals. 0 to 2 and 7 to 10. When is the object increasing its velocity north?
4 to 17. I mean 4 to 7.
Yep. When is the object decreasing its velocity east? That's a typo. Can you cross out the word east and put the word north there? I was cutting and pasting from the above question. Oops.
0 to 2.
Yep. Oh, when are we moving at a constant velocity? Okay. So are you getting the hang of this? You can think slope, but when you're thinking slope, really you can think acceleration, increasing, decreasing, or constant velocity. They're interchangeable. A lot of information in a graph. All right. Let's try sketching our own. What would a position time graph look like if you had an object that was accelerating? Well, sketch V versus T graphs for the following. So take a look at this. Now, what kind of a graph is this? Is this a velocity time graph that I gave you? This one here? Okay. So, key idea. It's a distance versus time graph, Oscar. What's the slope of a position versus time graph? Not acceleration. What's the slope of a position versus time graph? I'll give you a hint. I'll give you velocity. These are the 2 slopes. Position versus time, slope is velocity. Velocity versus time, slope is acceleration. So now I'm giving you a position versus time. What can you tell me about this slope? Is the slope changing or is it a nice straight line? Constant. Positive, negative, or 0? So you know what? I can tell you that this velocity must be positive but not changing. I don't know how high it is, Sarah, but I can tell you that if you were asked to sketch the velocity, you would sketch something, no acceleration. Now, if that confuses you a little bit, hang on. Look at B. What's the slope of B? What's the velocity of B? That would be a line that would look like this. 0 high. Because on this graph, your height is your velocity. What do you notice in part C? Our slope is getting steeper and steeper and steeper and steeper. You know what that means? The slope is changing. You know what that means? The velocity is changing because the velocity is the slope. Increasing or decreasing? That would look like this, getting steeper and steeper and steeper and steeper and steeper. Getting higher and higher and higher because on the velocity time graph, Justine, your height is your velocity.
Do you have to draw arrows at the end?
I'm not fussy, but technically we should, since you asked. What about this last one here? Starts out fast, steep, yes, and then gets what? Less steep. Oh, you know what? Starts out fast and gets slower and slower and slower and slower and slower. You see it? These are tough. Don't kid yourselves. If you find these tough, you're normal. A couple more practice ones, and then I'm going to turn you loose, and we are done the unit. We're going to do a couple of sketches just using our imagination. I called this sketching velocity versus time graphs. I stole this from the internet. Okay, so here we go. It says sketch velocity versus time graphs. By sketch, all I mean, Kenzie, is get the slope right, positive or negative. roughly. It says the object is moving away from the origin. Let's call that forwards at a constant speed. So you have a positive, you're moving away, you're moving forwards at a constant speed. Now on a velocity time graph, Brad, how high you are is how fast you're traveling. So let's decide that you start out traveling that fast, right there. Put a dot right there. Yep. This is why I said we're going to define it as forward positive so that we all get the same thing. The only thing I don't like about this is the vocabulary that they use, and I'll probably change it next year, but I only found this last night at about 8 p.m. So, after 1 second, has your speed changed according to this question? Psst. After 1 second, has your speed changed according to this question? Yes or no?
Yeah.
I heard yes and I heard no. Someone convince me. Constant speed. So after 1 second, you'd be at the same speed? Because the height is your speed on a velocity time graph. After 2 seconds, you'd be at the same speed? How fast would you be traveling after? Oh, can you see, if I'm sketching this, Hayden, it's going to be a horizontal line. By the way, what's the slope of that horizontal line? What's the acceleration of this person? Zero. Why? Constant speed. Now, Hannah, if you drew your line a little bit lower, I'd give you full marks. I didn't tell you how fast, I just told you forwards. If you drew your line higher, as long as it's horizontal, I'd give you full marks. That's why I wrote sketch and I didn't say graph. We're just going to sketch. What about if the object was standing still? What would that look like? All lines are straight. Horizontal line, how high? That would be this one. Because how high is that line? 0. What's your velocity? 0. The object moves towards the origin. Let's say it's coming backwards towards us. It's coming backwards towards us. So we're going to call this backwards. At a steady speed for 10 seconds, and then stand still for 10 seconds. You know what? Right here, put a 10. Right there, put a 20. We'll divide it into two 10-second intervals. How would I show traveling backwards at a steady speed or coming towards us at a steady speed? Not a negative slope, a negative line, but because it says steady speed, the slope is still 0 because the acceleration is still 0, right? And then how would I show standing still for 10 seconds? Another horizontal line, 0 high. Number 4, the object moves away from the origin. We'll call that forwards at a steady speed for 10 seconds. Reverses direction. I think we'll call that backwards, Kenzie, because reverses, yes. And moves back towards the origin at the same speed. You know what? Let's put a little 10, 20 right there. How would I show moving forwards at a steady speed? Like that, maybe? You could be higher or you could be lower than my line, but yes? Now here's where I would be fussy. If I'm coming back at the same speed, first of all, will my line be above the x-axis or below the x-axis to show that we're traveling back below? And I would be fussy. I would look for exactly the same height as you went above, because if it's the same speed and the velocity is your height on a velocity time graph, so I'm going to eyeball it about there for me. Make sure you're the same height as you above as you were below. Is that okay, Ty? Turn the page over. Do these last couple, we're done. So it says, draw velocity time graphs for an object whose motion produced the position time graphs below. Okay, and now they gave us numbers, so we can be a bit fussier. How can I get velocity from this position time graph here? Oh, where does velocity appear on a position time graph? It's the slope. What is the slope of number 5 there, that first graph? Go rise over run, you have numbers. 1, positive or negative? So that would be a graph that would look exactly 1 high. You know what, Mr. Dewick? Use a thicker line. Number 6, can you see there's 2 parts? Which part is steeper, the first part or the second part? Where are we traveling faster, the first part or the second part? Speeding up, or sorry, going at a fast speed, and then we tap the brakes and slow down. What's the slope? Rise over 2 over 1. So for the first second, we're traveling that fast. Then for the remaining time, how fast are we traveling? What's the rise? 2. What's the run? 4. So the rise over run is 2 over 4, or as a decimal, what is that? 1/2. So you know what? I'll eyeball it about that high. That's that trip, apparently. What's that, Hannah? You want to do one more? I have one more for you. Because I care. This is, again, 2 different sections of a path. What's going on there in number 7 in English? What direction are we traveling in that first section? Forwards, and because it's a positive slope. What about in the second section? I wouldn't even say slowing down. I think negative slope. I think your velocity is negative. I think you've gone backwards already. I think the slowing down, I think what happened is right there. You hammered the brakes and threw it into reverse. You came to a stop instantly and whipped her into reverse right away. I think. What's the slope of this first section here? Well, what's the rise? What's the run? Hey, what's 2 divided by 2 in your head, please? No calculator. So for the first 2 seconds, how fast are you traveling? 1 meter per second. For the next 2 seconds, negative, which means I'm going to be down below the x-axis when I graph it. What's the rise? 4. What's the run? What's the slope? Negative, in lowest terms as a number. So the slope of this is -2 over 1, or just plain old -2. So that's going to give me from 2 to 4 seconds down there. What's your homework? Stuff to practice. So look up, please, and I'm going to shut up in about 2 minutes. The first sheet I gave you I called acceleration. It's got, first of all, a couple of graphs for you to interpret. Remember, they're velocity time graphs. How high you are is your velocity. The slope is the acceleration. If it's a position time graph, how high you are is your position. The slope is velocity. I didn't give you answers for the graphs, but then when you get to the questions here, do you guys have answers in the brackets in next to each question here? I did put answers for you guys, yes? I think I forgot to put it on my digital copy. But you guys should have answers. So you can try this. This is a good summary of everything. There's a couple of challenge questions. If you ever wondered, hey, Mr. Dewick, how do we calculate distance? This is an equation. Those of you that take Physics 11 next year, you'll learn next year. D equals VI times T plus 1/2 times A times T squared. But you know what T means. You know what A means. You know what VI means. You can try figuring it out yourself. That is your official, I'd like this done for Monday if at all possible. The second thing I gave you is a practice test. This is not homework yet. This is going to be due Wednesday. This is the great big review. But I gave it to you today because I know, Hayden, some of you, if you know you're going to be working Monday night and Tuesday night and you want to get a head start on your studying, you can start it now. I think I'm good with every question on here. It's pretty long, I know. I did attach the answers as well, so you should be able to work your way through this. Let me see, that looks good. Yeah, I'm okay with all of these questions here. Okay? I'm finally shutting up.